Okay, so can you please introduce yourself?
Yeah, sure. So I have around 3.2 years of experience as a backend developer. So primarily I am working with Java, Spring Boot, and microservices based architectures. And I have been involved in designing and developing a scalable backend services, REST APIs, and distributed system components. And my experience includes working with SQL and NoSQL databases also, such as MySQL, MS SQL, PostgreSQL, and MongoDB as well. And along with I have also experience working with implementing caching, messaging system, and optimizing the application performance. So I have experience with Kafka for the messaging queues and all. And in my recent project, like I have worked on the microservices based platform where I was responsible for building high performance services. So that we have integrated with the third party APIs, and like we have several modules, or we can say microservices. So like each teams like each developer is assigned with one module, and they work on that specific microservice. So apart from that, I also collaborate closely with the cross functioning teams, and guide the juniors also. So whenever they need, or whenever I have to review it, so those things also I do. So yeah, so this is what is all about myself. Yeah.
Okay, so what is your current project? Can you please explain its architecture?
My current project, yeah, so in my current project, I am working on a microservices based platform that handles the end to end processing of business operations such as onboarding, service activation, and it also has notification and analytics part. So all those things are there. So this system is mostly built using Spring Boot and Java, and this is fully distributed microservices architecture. So we have deployed it on containers, and architecture is basically we have here service layer, database layer, then event and messaging layer, API gateway, security layer, CI/CD development, and so these things are there. Monitoring and logs also is there. So coming to like in the service layer, like we have the application is mostly divided into multiple Spring Boot microservices. So we have user customer services like order service, notification service, then workflow service. So these are different types of services are there. And for communication, we are using synchronous as well as asynchronous both. So for synchronous, we are using a REST and fin client, and asynchronous, we are using Kafka for messaging queues. So this is what is about. And in database layer, we are using mostly Postgres and MS SQL. And for the messaging, as already told, that we are using Kafka for that. And then for API gateway, all clients request to, comes through the API gateway. So we are using Spring Cloud gateway for that. So and then coming to the for the security, we are using JWT tokens, and monitoring and logs, we are using ELK stack. So yeah, so this is what is all like tools and technologies and architecture of the my current project.
Okay, now can you please share your screen and write some code snippets that I will ask?
Yeah, sure. Yeah, so is it visible?
Yes. Okay, fine. So now can you write one simple code snippet for the Spring Boot controller class? So the minimal things I want you to write, like What is the bare minimum required in the controller to run the Spring Boot application?
Yeah, so if we want to write the controller, then first of all, so let me write here. So let's say we have any, for example, let's say we have any item controller. So we want to get the list of items or something like that. So let's say we have item controller. We can write like public class item controller. And then so we can have the CRUD operations here. So for example, suppose if you want to get the like get all items, then we can just write at the rate of get mapping, and we can just say like public list of items we want to get. So let's say we have item class, so list of items, and then get all, then we can simply return. Now we will also have to have service layer. That object we will have to auto wire here. Maybe if to keep it minimal, let's say we are trying to get it from the repository itself. So we can write maybe let's say any item repository is there. Item repository, let's say repo. So now directly from this object we can say find all. So it will get the all list of items, and again we will be also having this repository. It will look something like, let me write one or two line for this also. So public interface item repository extends. So this can extend either JPA repository or CRUD repository. So JPA repository provides more methods, so we can use this. So item, and uh, what will be the ID, I mean a data type of the ID primary key. So that also we give as a like second parameter here. So something like that it will be. So let me change this to Java so that it looks better. This is how we can get all items. So if we want to write the CRUD operation, so we have get mapping. Similarly we can have like uh, post mapping. We can have post mapping, and similarly we can have so in post mapping again we want to, if we want to submit any data, like if you want to create any entry to the database, so in that case we can use post mapping. And we also have put mapping, so all CRUD operations we can write. So this is how we can do it. Yeah.
So is this enough? Any other important annotations you are missing here?
Other important annotations, yeah, so the other important annotations, yeah, I think here we need to use at the rate of rest controller. So this is one, and we can also have here the request mapping, the the initial path for this request mapping, and then it will have let's say whatever URLs we want to get. So for example, let's say items. Yeah, so yeah, I think this way we can hit this get mapping.
Okay. So now let's suppose if I want to access using URL. So can you write that here? Copy from the chat. Yeah. Uh,
Yeah.
Okay, so suppose if I want to access using this, right? So what changes you need to do in your controller?
If you want to access using this, uh, in that case, I think this is get all, but we will have to write another get mapping. So instead of this get all, so here since we are calling based on the ID, so this is basically we will be using a path variable for this. So in the get mapping, first of all, we will be having here the ID. So whatever we are passing here, ID will be there, and then uh, we can just say like maybe get by ID. So get by ID. So and this instead of the list of item, it will be single item. So and it also might be empty, so we can use optional for this. And get by ID, and in this also like since this is a path variable, so we will be writing path variable here. And ID whatever the ID, and this data type also we write here. So since we are assuming this ID, I mean will be the long type. This is how I think we can hit this.
Okay, fine. Can you again copy the another URL which I have saved?
Yeah.
So now my objective is to get using this URL. So what changes will you do?
Okay, so this is basically called a query parameter. So uh, we use request param for this. So instead of a path variable, we have to write request param. So for example, in this we can so instead of so this is now not required. So get item, and this one will be request param, and here we can just say like item ID. Let me comment out this one because we are not I mean getting the all, we are getting the single item. So this is how we can do.
So what do you think is the difference between these two kinds of URLs and when we should use which one?
Yeah, so usually we use this one, the path variable one, um, because that is the clean way of writing the APIs. So they are used when the values represents a unique resource identifier. So then we can use this. So like when we have to suppose fetch item by ID, delete item by ID, or update any item by ID, then we can use this path variable thing. Yeah, so path variables basically match the resources. So they are from the clean RESTful URLs. And coming to this query parameter. So the query parameters are used when passing the like optional filters. So this is not suppose mandatory. We are passing is whatever is optional, and search criteria or sorting or multiple conditions are there. So sometimes we can also here we can have the and percent, and we can add multiple conditions based on which we want to get the item or filter the item or whatever we want to do, but these are kind of optional. So yeah, so this is what like mostly we use for.
Okay, so what design patterns you have used in your project? Can you explain the real world scenario?
Yeah, so in my projects I have used various design patterns. Like I have used a singleton, factory, and then I have also used builder. So these are design patterns mostly I have used.
What about with respect to microservices?
Yeah, with respect to microservices, I have used Saga pattern. So in my current microservices project, I have implemented this pattern to handle distributed transactions across multiple services. So, especially in the order processing workflow. So, for example, when suppose a customer places an order and the order service first creates the order in a pending state and then publishes an event consumed by the inventory and payment services. So each service performs its own local transaction, like reserving the stock or maybe charging the customer. So all these things are done here. And if any step fails in these, then the saga pattern is triggered. So it basically compensates the action, such as like releasing the reserved items or refunding payments. So all these are done. So we have to roll back whatever the steps has already happened, right? So in that case, we are using this saga pattern. So this basically ensures the data consistency without using distributed transactions. So it keeps the services loosely coupled. So like all are not uh, like kind of tightly coupled and not dependent on each other always. And it makes the whole system like more resilient, we can say. So yeah, so any kind of failure, like it does not makes a huge chaos, and it is easily handled. So yeah.
In Saga also we have different types, right? Do you know that?
Yeah, in Saga we have I think choreography and orchestration. Yeah.
So the example you explained, so which pattern it is?
Yeah, in our microservices system we used choreography based Saga because the workflow was relatively simple and event driven. So each service like was listening to events and reacted independently. So for example, when the order service published an order created event, then the inventory service consumed it to reserve the stock, and the payment service consumed a subsequent event to charge the customer. So basically, this approach keeps the services loosely coupled and avoid having the any central managing service. So they all were independently working. So we were using, I mean, this choreography based saga pattern. So yeah.
So how do you avoid losing events if one service gets down?
Yeah, so if suppose to avoid losing events when a service goes down, so uh, I mean we can rely on the Kafka. Kafka basically persists every message on a disk and replicates it across the multiple brokers. So even if the consumer, even a broker fails, then the event is still safely stored. So we are not losing the data, and when the service comes back up, so it simply continues consuming from the last committed offset. So because Kafka keeps the event history, the service can uh, replay any unprocessed events. So yeah, so this basically guarantees at least once the delivery and prevents the data losses even during the outages of the system. So the data will also always be there in this kind of setup. Yeah.
Okay, so now let's assume we have a Kafka running, right? So suppose that Kafka broker itself goes down, then what will happen?
Yeah, if the Kafka broker goes down, the cluster continues to run without like interruption because Kafka usually we don't have only one replication of that. So it is designed to be fault tolerant, and each partition has multiple replicas across the different brokers. So if the broker that was acting as the leader for a partition like that fails, then the Kafka automatically elects the newer leader. Okay, so the producer or consumer then switches to the new leader I mean at that time, so we don't have to worry about its failure. So it has multiple replicas. So since the data is already replicated across the brokers, so no messages are lost as long as the replication factor is greater than one. Yeah, so it won't make any issue. So
Okay, so now can you tell me what is service discovery?
yeah, we are using Kubernetes. So service discovery is handled through the Kubernetes DNS. So every service gets a stable DNS name, and the cluster automatically manages scaling and IP changes, and also load balancing as well. So this gives us a lots of flexibility when deploying or rolling out the new version. And since DNS is managed automatically, so we don't have to maintain something like we do in Eureka manually. So yeah, so this is happening like this way. But I have the knowledge of how Eureka also works. But yeah, in our project we are using the Kubernetes DNS.
Can you tell me how do you manage the configuration across the microservices?
Yeah, so for the configuration, we externalize configuration using the Spring Cloud config, and also we use Kubernetes config maps and secrets. So this way, like we avoid hard coding any value in the code base, and updates can be like rolled out without redeploying the app. That is how we can configure it, and it also gives us the better control over the environment specific configuration. Yeah, so this is how we are maintaining the configuration across the microservices.
Okay, and what is the role of an API gateway in your project?
Yeah, API gateway is is a single entry point for all the client request. So it handles routing, authentication, rate limiting, and even request response transformation whenever needed. So it simplifies the client side because they don't need to know about the multiple services. So client does not have to call the different services for different stuffs. So they can directly call the API gateway, and API gateway takes care of the rest of the things after that. So plus we get the centralized logging and monitoring through the gateway also. So that is also done in the API gateway. Yeah, so that is the role of API gateway.
And how do you handle distributed logging?
Yeah, we use ELK stack, so Elasticsearch, Logstash, and Kibana. So all services send logs with a there is a trace ID actually. So that is used with by the all the services. So we can track a single request across the multiple microservices easily. So it saves a lots of time during the debugging, and Kibana dashboard gives us the like kind of clear picture of overall the system health. So that we can check, and we can also use actuator for that, so we can get the health for that. So yeah.
So in your case, how you are testing your microservices?
So yeah, we are following a layered testing strategy. So we are doing first of all unit testing, and then we are doing integration testing, and then like contract testing, and then we are doing end-to-end testing. So these are the layers we are following, smaller to higher level. And contract testing basically help us to ensure that person consumer expectations are matching properly. So yeah, so this approach basically helps us to catch any issues early. So this is how we are following the testing.
Okay, and in Spring Boot, what is Spring Boot starters?
Yeah, starters, we can say like they are predefined dependency that bundles the and simplify the setup basically. So we have, for example, let's say Spring Boot starter, web, and test security. So all these are different type of starters. So for example, this web includes everything needed to build the REST API. So we don't have to separately go and check like which version of jars they are supporting each other and download and add it. So those things are not required. Similarly, suppose if we have Spring Boot starter JPA, so like hibernate versions and all, we don't have to worry about it, that compatibility of those jars, right? So basically they ensure all libraries inside the starter they work well with together, and that avoids any kind of version mismatch and makes the project setup like very much consistent. So user don't have to the developers don't have to focus on the project configuration and all, and they can simply start their development. So yeah, so that is what is the Spring Boot starters. Yeah.
Okay, also can you tell me how do you implement validation in a Spring Boot?
Yeah, so we have some annotations like at the rate of not null, and if suppose email is there, at the rate of email is there, at the rate of valid is there. So these kinds of tags we have, at the rate of size is there. So these kind of tags are there that we can use. So Spring automatically returns the error message if the validation fails. So these validations fail. So it keeps the API very much clean and ensures the data entering the system is correct. So yeah,
And it is found under which package?
yeah, I think Java X dot validation. So I think we have to import that.
Do you know lazy initialization? So how do you basically enable this?
Yeah, to enable lazy initialization, we can use like I think we have annotation at the rate of lazy annotation. So that we can use on the specific beans. So that makes the Spring to create the bean only when it is actually needed instead of at a startup. So we can also enable it like globally by adding the uh, we have I think one uh, parameter. So I think lazy initialization equal to true. So something like that we have to do in the application properties. We can add that. So in that case, it will be applicable for all the global beans. So this basically helps to reduce the startup time, and especially when there are many beans. In that case, we can use this. So in microservices, it is useful whenever the service starts slowly and due to heavy dependencies. So yeah,
Okay, since this lazy initialization has this much of advantage, so why don't we always use this, or it should be default?
yeah. So we usually we don't enable this globally because like lazy init can hide the problems that would normally appear at the startup, but whenever this we make it true, in that case it won't show all those issues. So with lazy initialization, some errors only show up when the bean is accessed during the runtime. So that can maybe that can lead to unexpected failures in the production and all. So this is kind of risky, but yeah. So but whenever we have like lots of beans and it is too heavy and it is properly tested each and every bean, so in that case, yeah, we can go for it. So yeah.
Can you tell me the difference between save and flush? Do you know that?
Yeah, save and flush is used in Spring Data JPA. So save basically that persists the entity but does not immediately push the changes to the database, and the flush may happen later, like at the end of the transaction. So it acts kind of it is lazily, and save and flush that saves the entity and immediately flushes the persistence context to the database. So this basically forces an actual SQL right at that moment. So it is useful when we need to update the data instantly. So that time we can use 7 plus. Otherwise, save is also fine. So yeah,
Okay, so you have experience in Java 8, right?
yeah, I have.
So can you tell me what are the features of Java 8?
Yeah, Java 8 mostly has like streams, lambda expression, functional interfaces, optional, then new datetime API. So these are the features there are there.
Okay, so what is functional interface?
Yeah, functional interface is an interface with exactly one abstract method, and it can have any number of default and static methods. So Java it basically uses this to support lambdas. So for example, we have runnable, callable, and all. So they are the functional interfaces. So yeah, so that's what is the functional interface.
Okay, so can you write a simple functional interface?
Yeah, sure. So So let's say we have any for interface. Let's say we have like public interface, and let's say greeting service. Okay, so we can just say what greet. Yeah, so this is one abstract method, and yeah, so this is all. There's no need to write any other method. If we want, we can write like uh, default methods also. So let's say default void say hello, and we can write here. Yeah, so we can have this also. Yeah, so this is one of the functional interface.
So annotation is not required.
Yeah, annotation is optional, so it's better to write it. Um, like we have added a functional interface, but that is basically only uh, required to make sure that whatever the interface we have written, that is functional interface. So the rules we are not violating. So for that purpose only that is required to write. Yeah, so we can write it.
Okay, now let's say, can you write one more method? So press enter after line number 53.
Okay.
Can you write boolean equals and just give just give object obj in the parameter. Yeah, semicolon. Yeah. Now tell me, is this allowed? Is this still a functional interface? Now we have two abstract methods, right?
Two, I mean, see, this one we don't count as abstract method because this has come from the object class. So we are simply overriding it from there. So as we know, object class is the base class for any other classes. So any method from the object class is not counted here. So yeah, it is still functional interface, and it won't throw any error.
Okay, fine. So now can you tell me what is the difference between hash map and concurrent hash map?
Yeah, hash map is not thread safe and can lead to data inconsistency in a concurrent setup. So concurrent hash map is thread safe, and it uses a lock on a block mechanism internally to avoid the blocking the entire map. So on a specific bucket only the lock applies. So reads are mostly lock free in this case, and only a small portion gets locked during the writes. So that's why like we always prefer concurrent hash map in like microservices. Yeah, so that is the difference between these two.
And what is the difference between double equal to and equals?
Yeah, double equal to checks the reference equality, and equals checks the content equality. So the whenever two references points are the same object, then we do using double equal to, and equals is like comparing values inside the objects. For example, two different integer objects with the value 10 may not be double equal to, but they will be equals. So that will return true because their content is matching. So yeah, so that's the difference between these two.
And what is the difference between a string builder, and buffer?
Yeah, string is immutable, and string builder is mutable and not synchronized, and string buffer is also mutable but it is synchronized. So that's the difference between like these three. So string, like every modification creates a new object, and string builder is like it is faster, and since it like it is mostly used in the single thread scenario, and a string buffer, like it makes the thread safe. So like because it is mutable and synchronized, so it is thread safe. So it is slower than the string builder. So that's the difference between these three.
And what is the purpose of final keyword?
Yeah, final can be applied to variables or methods or classes. So anywhere we can apply. So a final variable, basically it cannot be reassigned, and a final method, it cannot be overridden, and final class cannot be extended. So that's the purpose of the final keyword. Yeah.
Okay. And what is class loader?
Class loader, it loads the Java classes into memory at runtime. So Java has three main class loaders like bootstrap, extension, and application. So in Spring Boot, custom class loaders are sometimes used internally for the things like dev tools and all. So yeah, that's what is the class loader.